Welcome to Unit 2. Our first topic in Unit 2 is called Adding, Subtracting, and Multiplying Polynomials. The entire unit is called Equivalent Algebraic Expressions, and we talk specifically about that today. The distributive property. This is review. Anything that's touching a bracket must be distributed entirely into that bracket by multiplication. So we take this a, we multiply it by the x. A times x is, of course, ax. Oops, trying to get my pen. Here we go. A times x, we do that first. And that gives us ax, and so on. The a is touching the bracket, so the a has to be multiplied into each thing inside the bracket. There's three things in there. It's a trinomial. So we should end up with a trinomial. Proper form. Algebraic terms are always written in alphabetical order and then by descending powers. So not y cubed x squared, but x squared y cubed. Why? Read the definition again. These are actually exactly the same term, but they're just not written properly. This one's not written properly. What's the reason? Well, the reason is they have to be in alphabetical order, and x comes before y, so we have to switch these around. Also, we would not write this trinomial this way, but we would write it this way. And what's the reason for that? Same thing, alphabetical order. So the m has to come before the n, and the constant is always last. So whenever you have a constant in an expression, that's always the last thing written. Okay, expand and simplify. This is good. This is a good slow start to our lesson. This you would have done in grade 9. We distribute the 4 in with multiplication. Negative 4, so we'll do the number times numbers. That's going to be a negative 8, and then a b. And then negative 4 times negative 3, that's a positive 12. Now you take a look at these two. Can they be added or subtracted? No, they're not like terms, so we can't go any further. B, this one's harder. In front, this is a monomial. It's one term. It's got two parts to it. It's got an x and a y, but since they're attached with multiplication, there's no plus or minus signs in the middle there. It means it's a monomial. So monomials get multiplied as an entire term into the bracket. So I take this entire x squared y and I multiply it into the first big term there, which is 4xy. So first we do the numbers. There's an invisible 1 in front. So 1 times 4, that's a 4. Then we go to the x's. Here's an x squared times an x. We add the exponents because we're multiplying like bases, and that's x cubed. Then the last thing we have is a y. We multiply it with its like term, which is a y. Y times y is going to be y squared. Okay, so that's the first one done. Now let's go to the second one. Switch colors. So now I take my x squared y and I'm going to multiply it by the second term. First the numbers, so in front is invisible 1, 1 times a negative 3 is a negative 3. X squared times x is x cubed again. And then y times y squared is going to be y to the power of, remember we add the exponents, 3. One more to go. And then we'll be done this because we've got a trinomial there. So the last one, x squared y times the last term. They both have a 1 in front. The coefficient is a 1 in both cases, so that's just going to stay the negative sign that's there. Remember the sign goes with the number the term that's after it. So that's a minus 1. You don't have to write the 1. X squared times x squared is x to the power of 4. Y times y squared is y cubed. I'm not sure if I've said this before or not, but if you're ever watching a video of mine and there's a mistake, please message me so that I can go back and fix it, because as I'm writing this stuff down, I'm thinking of 100 other things, whether or not I need to explain it to you, so I do sometimes write the wrong thing. Sometimes I'll be saying negative, but I'll be writing positive, so please let me know. Anyway, we're going to look here at what we've got left. We want to see if there's any like terms. Like terms are defined by the bases and the exponents. So here's an x cubed y squared. This is an x cubed y cubed, so they're not the same. And this is an x to the power 4y cubed, so it's not the same as any of these. So we don't have any like terms, so we can't add, we can't collect any further. Now C. So if you think you've got the hang of this, why don't you press pause and do the next line yourself. I'm going to do it. I'm not going to do it with a lot of explanation, but I'm just going to write it out, and you can press pause and then press play again when you're done just the next line. So first we start with an equal sign. You have to start every line with an equal sign. It's telling me that this line is equal to that line. You must put it there for proper form. Okay, I'm distributing here. 2 times 4. That gives me an 8a squared. That's these two. Keep going. Minus 12ab, alphabetical. The a goes before the b. And then plus 2a squared b. Now this negative a, yes, it's a negative a. The negative sign comes in with it. So that's negative a cubed. And keep going. Positive 3a squared b. And distribute over here. Negative and a negative, we have a positive 6 and alphabetical ab. And then at the very end, we have this a cubed, which is just on its own. So now we look for any like terms. So like terms, let me go to green here. Let's start with the a squared. Is there any other like terms with a squared? Well, this one has an a squared, but it's an a squared b, and the variables have to match exactly, so they don't. So that one's not a like term. We've got a 3a squared here. Oh, but there again's a b, right? That's a squared b, so nope, that's not a like term either. And then we've got an a cubed at the end. So that's our only a squared. So let me write that out here. I'll just use black. That's 8a squared. Okay, now if you look back up to the proper form line, the algebraic terms are written in alphabetical order, then by descending powers. So alphabetical order, I've got to stick with the a terms here. Actually, I'll reorganize it in my next step. Let's just keep going and collect here. Okay, let's go with the 12ab. This is an AB. Are there any other just ABs here in the list? Yes, right here. So we've got a negative 12ab plus 6ab. That's going to give us negative 6ab. Now let's look at the a squared b. A squared b, are there any a squared b's? Yep, right there. So that is 2a squared b and 3a squared b. That gives you 5a squared b. And then the last one, just going through our list, is an a cubed. Now it's a negative a cubed and a positive a cubed. So what's that going to give us? That they're going to cancel out. So they're gone. So let's go back now and talk about our proper form, because in math, if you don't use proper form, it's just as bad as your English class. You don't start a sentence with a capital or end with a period or use the right grammar or the right punctuation, you're going to lose marks. Same thing in math. And one of them is not starting with an equal sign. If you don't start a line with an equal sign, it's like not starting with your capital. Okay, for these questions expressions. There should be one equal sign per line. So I should not right here put equals and then put an answer over here. One equal sign per line. So my next line is going to go below. So none of these are like terms. We've already collected all of our like terms. We're just going to put them in order. And the back of the book isn't that great. They get a bit lazy with this. So we have to go with the highest power of alphabetical order. So alphabetical, they all have A's in it. So how do you know which one goes first? So we're going to put the 8a squared first. And then after it, we're going to add on the 5a squared b, because it also has an a squared, which is the highest power right now, but then it's got a b on it, which is kind of bringing down the alphabetical order by a notch because it's got a b. Then after that becomes a 6ab, and that's because that a only has an invisible exponent of 1, so it falls after the other two. And you're kind of used to that notation. In grade 10, you would have had a lot of questions like 3x squared plus 2x plus 5, oops, 25, okay, plus 5. See, I just did it there. I was saying a 5, but I wrote it. So here's the highest power here, and here's the next highest power, and then the constant goes at the end. So you're already used to kind of writing it in that order. It's just some of the questions today are a little more complex. The previous examples all involved multiplying a monomial by a polynomial. So mono meaning one term by many terms. That was grade 9. So now we're going to talk about review from grade 10. They involve multiplying binomials, that means two terms, like x plus y, with another binomial. Remember to distribute everything into brackets and to follow the order of operations. Expand and simplify. Look, we've got three things here. We've got this binomial, this monomial, and then another binomial. So I'm going to remind you of FOIL. Actually, let's start first. Now, when you have three things you're multiplying together, it doesn't really matter which order you do them in. So just to keep it kind of tidy, I'm going to multiply these things first, and I'm going to leave this. So here's my equal sign, but I'm going to leave that x minus 7y. I'm going to do that later. So I'm not doing anything with that right now. I'm just multiplying the first two. So 3x distribute 3x times x. That's 3x squared. And I'm putting a bracket at the front because I still have more to multiply it by. Remember, there's still more, so I need the bracket. And then negative 2y times x is negative 2xy. And the bracket. Now, this is binomial. These are both binomials here. They both have two terms in the brackets. And an acronym you might have been taught in grade 10 is FOIL, which is first, outside, inside, last. If you don't know that, that's fine. It's just a way to help you remember that you're getting all the combinations. So really what you're saying is I want to take this is the first term in this bracket, and here's the first term in this bracket. I'm going to multiply them together first. That's just what FOIL is, but you don't need to know that. Really, officially it's called binomial distribution because we're just distributing binomials. So first I take the 3x squared and I multiply it by the x, and that's going to give me 3x cubed. Now the 3x squared, so the 3x squared has to get multiplied into both terms here, so I'm going to multiply it by 7y, and that gives me negative 21, x comes first, x squared y. Now we've taken that 3x squared and we've multiplied into both terms of this binomial, so that part's done. Now I'm going to go on to the negative 2xy. I'm going to multiply it with the first term. That's going to give me negative 2x squared y. And then by the last term, that'll be a positive 14xy squared. Do we have any like terms here? So take a look. Does anything match? Yep. Right here, we've got x squared y. So my final answer is going to be 3x squared, or cubed, sorry. And then there's a negative 21x squared y minus 2x squared y. That gives us negative 23x squared y. And then the 14xy squared. And now let's take a look and make sure it's in order. And it actually is in order because we're starting off. So you look at alphabetical order. So the x's come first, and there's an x cubed. That's our highest power, so that one definitely goes first. Then there's an x squared, and then there's a single x. So you could actually switch these two around. Sorry, no, you can't. This is an x squared, and this is just an x. You can't switch them around. Okay. Now up to B. The most common mistake students make, even into grade 12, is they think that that exponent 2 means they can just distribute an exponent backwards like this and write it as 16m squared minus 81n squared. Totally wrong, and you should know that even from elementary school that that's not what exponents do. The reason sometimes students do that is because when you first learned about exponents, you talked about monomials. So if you just had 4m squared, just a monomial, so that's the same as writing 4m times 4m, which is 16m squared. So it's like you're taking the exponent, right? Because it's a monomial, that's exactly what you're doing. But as soon as you have a binomial, You can't do that because the power of 2 means this. It means you're writing it out twice. It's just that we skip that step a lot. So I'm going to start by writing this line out twice. So the 3 is not affected by that power of 2. The power of 2 is touching the bracket, so everything inside the bracket has to be written out twice. Like that. Now we can distribute. So you can distribute first if you want these two and get your answer and then just rewrite this 4n minus 9n. Or we're going to do it the other way this time because that's the way we did it last time. This time we're going to distribute first these two. So I'm going to leave the 3. Let me move my equal sign down. I'm going to leave the 3 at the front. I'm not going to distribute that yet. I'm going to do the brackets first. And I usually like doing the brackets first because that's the harder part, so I like to get that straightened out first. 4m times 4m, 16m squared. 4m times negative 9n is negative 36. Alphabetical, mn. I'm going to run out of room here. Oh, that's okay. Now these two terms is negative 36 mn. And the last two, 81 n squared. So I have some like terms inside the bracket. So let me just collect those. If I didn't notice that, it's okay. I could collect like terms later. But these two are like terms, negative 36 mn, negative 36 mn. So that is a minus 72 mn and then plus 81 n squared. Now I can distribute the 3 into the brackets because I collected my like terms already. So first you're going to do 3 times 16, that's 48 m squared. And now we need to do 3 times 72, although it's a negative, that's going to give us a negative 216 mn. And then 81 times 3 is our last one. We're just multiplying the numbers first because there's no other variables to do. So it's 243. Yes, 243. And then n squared. So we take a last look at our answer here to see if there are any like terms and to see if it's in order. So there's no like terms. Is it in order? So alphabetical first. So there's an m squared. That trumps everything else. That gets to go first. Then any more m's? Yes, there's one there. So we have to. So this is in the right spot. And then this is the last one, n. Even though the n is squared, sometimes the tendency is to put it over because it's squared, but it has to be alphabetical first. So this m is going to come before the n. I'm going to have to erase this line here so I can do this question. So I'm going to do that right now. So you pause yours as well if you haven't finished copying it down before I erase it. Okay, last one. We've got a binomial here. This one is 2 terms, so it's a binomial. This one's a trinomial. Binomial times a trinomial. So we have to make sure every combination of multiplication gets covered here. So I'm going to start with my 3a at the front. So the 3a has to be multiplied by all 3 terms in this trinomial. That's my first step. So I'm going to get 3a. Actually, now's a good time to press pause and do it yourself if you want. And when you come back, if I'm going too slow, just skip ahead to the answer to see if you get the same answer. So we've got 3a cubed minus 15a squared plus 3a. Now the negative 2 comes into all 3 terms with multiplication, and we get negative 2a squared plus 10a minus 2. Now I'm looking for like terms. I'm going to start with the 3a cubed, no other a cubed, so that's going to stay 3a cubed. Now I go to the a squareds. There's negative 15a squared and negative 2a squared, so they are going to be negative 17a squared. And we've got an a and a single a here. That's 13a. And this is our only constant at the end, minus 2. And Is it in order? That's the last thing you take a look for. Is it in order? Yeah, they're all a's, so that's easier. So it's just the highest power first. A cubed, a squared, a to the power of 1, and no a. And technically, I'm just going to put this down for you so you know. Inquiring minds want to know. This -2 is really, if you want to be technical, you could put -2 a to the power of 0, because a to the power of 0 is 1, so that's really -2 times 1. We never think of it like that, but I just put that in there just for some little addition for you. That's why it goes at the end, because its exponent is the 0 exponent. So that is our review of expanding and simplifying. Example 3, use two different methods to show that f1x and f2x are equivalent. That was, remember the title of this whole unit, equivalent algebraic expressions. So we want to talk about what's equivalent, what's equal to each other. We're going to start with, of course, expanding here. Here's some ways that you can show whether or not two different expressions are equivalent. Expanding is one that we can do here because we have expanding that needs to be done. So I put my equal sign underneath the equal sign that's there, and I distribute with binomial expansion. I'm expanding my binomials or FOIL. That's 3x squared plus 6x minus x minus 2. And often when you're expanding binomials, your middle terms are like terms. So that gives me 3x squared plus 5x minus 2. So the question says use two different methods. So the method I'm using first here is expanding. So I'm going to expand this one. And there's not much to expand here. I only have a negative to bring into the second bracket. So there's my equal sign, lines up with the other one. I'm just going to drop these brackets because there's nothing in front of them. But this negative has to come in. So all of the signs are going to change. And now I'm going to put it all in order and collect like terms. So I'm going to start with my highest power first. That's the 3x squared. So I'll write that first. I'm going to go with my x's. I've got a minus 2x and a positive 7x. So that's plus 5x. And then my constants give me minus 2. So it's equivalent. These two are equivalent. And let me just write that out there. Therefore, f1x is equal to f2x. We got them to be the same thing. Now the question says try another method. So we tried expanding. Another method we could use is graphing. That's the last one there. That might be, and that means going back to the original. Okay, go back up to the original here. So now we're just looking at these two. Don't look at what we just found by expanding. We're doing a different method. So I don't really want to graph those things. They look kind of, this one's not too bad. I could graph the zeros and find the vertex, but this one looks pretty difficult to graph. So let's try something else. How about subbing in a value? Let's try that one. So we pick a number that is not 0, but you want to pick something that's easy enough to work with. So let's try subbing in a 2. 2 is good. Subbing in a 2, that gives me, so I'm going up to the original. 3 times 2 minus 1, and then 2 plus 2. So everywhere I had an x, I put in a 2. That gives me 6 minus 1 times 4, or 5 times 4 times 4. That's a 20. Let's try, oh, switch colors, sorry. Let's try the same thing, subbing in a 2. You have to sub in the same number, of course. Try subbing in a 2 into the original, must be in the original. 7 times 2 plus 8 minus 10 plus 2 times 2 minus 3 times 2 squared. Okay, this gives me 14 and 8. And so we're following the order of operations, of course, very important. Order of operations inside this bracket. I do not do 10 plus 2 first and get a 12. I'm going to do 10 plus 4 there. And I do not do 3 times 2 first and then square it. I have to follow the order of operations, so I have to do the 2 squared first. That's minus 3, and that'll be times 4. So in our first bracket, we've got a 22, so I can drop the brackets off there. Minus, let's just clean this up a bit. We've got 10, I could add those, but 10 plus 4 minus 12. That's what's going to be in our bracket there. So 22 minus, what is 10 plus 4 minus 12? Well, that's going to be 2. And we get 20. So we proved that they were equal again by subbing in a value. So this method alone, subbing in a value, isn't enough. You can't just use that method if you are asked to prove equivalency, and I'll explain why that one alone isn't enough. Expanding is enough on its own. If you only had to show one method, you could just show expanding. That would be good enough. So let me tell you what I'm talking about here. Subbing in a value may show equivalence, but that could just be luck. Maybe you found the point of intersection. So those two questions were quadratics that we had there. Maybe you just found where they crossed each other. You need to try a second method as well. However, when proving non-equivalence, so if you're asked to prove that they're not equivalent, you can just sub in a value that won't make both equations equal, and that's sufficient. Why? Because if I have, let me draw a parabola here. If I have a parabola, I'm going to do two of them, well, two colors. Let's say I have this parabola, and I have this parabola. Okay, they're going to intersect twice. You can see they have 2 points of intersection. So maybe when I was earlier, if the question said prove whether or not they're equivalent, and all I did was sub in f at 2, and let's say this value right here, that point of intersection, let's say that point of intersection is 2, 1. So I would find by subbing in f at 2 into the purple one and into the blue one, I would get the same answer on both. So I might wrongly say, oh, well, these equations are exactly the same because I got them to be equal to each other, but they're not. So that's not good enough. That could be just you finding a point of intersection. However, if you're asked to, if you do it the other way, let's say I put in a -2 here. Maybe I was finding f at -2, and that would be, -2 would be over here somewhere. So f at -2 on the purple one is way down there at the bottom. F at -2 on the blue one is maybe up here somewhere. They're not going to be the same. F at -2. So as soon as you find, as soon as you sub in and you find an x value that does not show that both functions are equal, that's enough to show that they're not equivalent. As soon as you find one of these, you can stop. You can say, okay, they're not equivalent because I found one spot. They only need to not be the same in one spot to not be the same everywhere. So I could have a parabola here, and then I could have another parabola. I'm going to draw it almost exactly on top like this, but say it's not quite the same. If you can just find one spot where the two parabolas aren't equal, then they're not equal. So let's look at this question that was in the textbook. So, are these expressions equivalent? So just look at what they've got here is x, y's, and z's. So what if I said, I'm going to sub in 0 for x, y, and z. If I subbed in 0 here, 0 for x, y, and z, 0, 0, 0, 0, I'm going to get 0 equals 0. But if you look at, and this person did sub in 0 for some of them, but they also used a 1. They found the expressions were not equivalent. They shouldn't even have used a 0 at all, because 0 turns everything into 0. So even though they just used 1, I think they used 0, 1, and -1. They used 2, 1. Don't even use 0 at all. It's a bad idea because zeros turn everything into zeros, and it might look like your functions are equivalent, but they're not, just because you got everything to equal 0. So let's talk a bit about order of operations and multiplication. Is this the same as this? Think about that for a sec. So that's like, I'm asking you, basically I've taken the -2, multiplied by the -3, that's this one. Then I took the -2, multiplied it by the 6, that's showing this one. And then the last one would be -2 times 4, that's this one. So are these the same? Well, let's see. You can get out your calculator if you want to. But the way you would multiply this first one on your calculator is all at once, right? So multiply all of those together at once, and what do you get? You get negative 144. And as you were typing it, you probably noticed, as you're putting it in your calculator, you only used the negative 2 once. You did negative 2 times 3 times 6 times 4. You didn't do this. So now, if I look at this one here, negative 2 times 3, that's a negative 6, times negative 2 times 6, that's a negative 12, times negative 2 times 4 is a negative 8. So what happens when you multiply all three of those together? You get negative 192. When you're multiplying monomials, like we are here, when you're multiplying monomials, those are all single numbers. You don't distribute over and over again. So the reason I'm pointing that out is we're going to look at example 4. Example 4, see, it's got a power of 3 on it. So I'm going to remind you of what I said before about this outer power. This does not mean you take that power and put it right here and make that an x cubed, and then you make this an y to the power of 6. That is not what the exponent means or has ever meant. It always means you're writing this out 3 times. It means there's 3 of these. The 3 is touching the brackets, so we write out the brackets 3 times, okay? So that has to be written out 3 times like that. When I expand, so I expanded here, but I just expanded, I did these together, that's here, and then I did these together, that's here. I do not bring this negative 2 into this bracket, which I did first here, but then I don't take it out and then bring it back in again and again. Once I've brought it into one bracket, then it's there. It already exists inside this first bracket here. It already exists in there. The negative 2 is in there. So I will be bringing it into this bracket, but it's already incorporated in there. I don't need to take the negative 2 and multiply it into these two, and then the negative 2 into these two, and then the negative 2 into these two. Once you bring it into one bracket, it's there. Just like right here, negative 2 times 3, that gives you a 6, then you multiply it by that 6. I don't keep bringing the negative 2 back in over and over again. It was done once. So I've gone ahead and done these steps here. I've done this distribution. Now the next thing is, are there any like terms inside each bracket? This bracket has no like terms. This bracket does. The middle 2 terms are the same. We've got a negative xy squared and a negative xy squared. That's going to make a negative 2xy squared, like terms. Now we have to distribute everything from the first bracket into the second bracket. So the negative 2x has to come into all 3 things of this trinomial, and then 2y squared comes into this entire trinomial with multiplication. So if you want to press pause, do that now, and then when you come back, I will put the answer up for you. And there's the answer. Oh, and there's an arrow. There's what we have here. Now, any like terms here. So we've done all the multiplication. Let's start with the first term here, negative 2x cubed. So there's an x cubed. Are there any other x cubes? No. So I'll just write that again. Negative 2x cubed. Next term is 4x squared y squared. Any more of those? So I've used that one. 4x squared y squared. Yeah, there's another one right here. So I got 4x squared y squared and 2x squared y squared. That's 6x squared y squared. So those are gone. Now I've got xy to the 4th, xy to the 4th. They're both negative. Negative 6 xy to the 4th. And then I've got my 2y to the power of 6 at the end. So are these in order? Alphabetical first. So the first thing we're looking at is the x, and there's our biggest x. It's an x cubed, so that definitely goes first. After the x cubed, we've got an x squared, so it comes next. And still at x, staying with the x's, we've got a plain x there. And then this one has no x's. It's a big power of y, but y comes after x, so it goes at the end. So this is all in order. All right, now we want to see, remember the question's asking, are these equivalent? So we've got this and this. Next one looks a little easier because I don't have that power of 3. I'm going to start by distributing here and here. Actually, I'm going to start with an equal sign. Negative 2x cubed. That's my first part, and then I have negative 4x squared y. And distributing the 8 in, 8, I put the x first, y squared minus 8y cubed. Do we have any like terms? No. Is everything in order? Yes. So do they match? Are they the same? Are they equivalent? No. Therefore, they are not equivalent. And that's the end. When you do your homework, please remember to write out the question first. So just like what we have here in this last example, if this says question, 5B in your book, write out 5B and then write this out and then show your work underneath. You always start by writing the mathematics. You don't have to write this word, the sentence part or the instruction, but as long as the math is pretty straightforward, you're just showing some algebra, then you have to show that line first. And that way, it's easier for you to find your own mistakes later. You're not always going back to the textbook and saying, why did I get this wrong? Well, start by writing out the question. Don't skip this step. That is the end of your first lesson in Unit 2.